Assalamu alaikum, students. Today I will solve A-level paper 4, May June 2022. Now let's start the paper. In question 1, small smooth sphere A and B of equal radii of mass 5 kg and 3 kg respectively lie on a smooth horizontal plane. Initially B is at rest and A is moving with towards B with speed 8 meter, 8.5 meter per second. The sphere collides and after the collision, A continues to move in the same direction but with quarter of speed of B. Now here two spheres of radii, equal radii given. The masses of two spheres is 5 and 3 kg respectively. And we draw the sphere A and B here. To find the speed of B after collision, firstly we write the data given in the problem. Here the data is given. The mass of ball A is 5 kg and the mass of ball B is 3 kg, and same as the speed of ball B is at rest between 0 and the speed of A is given is 8.5 meter per second. And this is the data before collision. After collision, the speed of A and speed of B. Now the speed of A is 1/4 of the speed of B. Therefore, suppose that after collision, V A is 1/4 to speed of VB. Now we for VB speed is B. Therefore, the speed of VA is become 1/4 into V. Now I formed a figure here to understand this of sphere A and sphere B. The movement of there is the movement of sphere is showing that the ball A is moving towards B and the ball B is at rest. You can see here, and the speed of ball A is 8 meter per second. After collision, the speed becomes changed. The speed of A becomes 1/4 of speed of B. The speed of B is given as 4. Now from these data, we can find the momentum before collision. P A plus PB. Now the momentum formula is given here. P is equal to mv. Now we write it. The P A is 5 multiply 8.5 kg, 8.5 plus PB is 0 multiply 3 multiply 0. Here is the mass is 3 and multiply 0. Therefore, the total momentum becomes 42.5 kilogram meter per second. This is the momentum. This is the momentum before collision. And after collision, we find the momentum here. We use the formula same as the momentum after collision. PB, PA dash plus PB dash. We write this name as. Now here the PA dash will be equal to M into PA, M into VA plus MA into VA plus MA in MB into BB. Now we write the values here. 5 multiply VA is given 1/4 V plus MB is given. MB you can see here is the 3 multiply V. That value is equal to 17/4 V. This and according to law of conservation of momentum, momentum before collision equal to momentum after collision. We write it as here momentum before collision equal to momentum after collision. Now the total momentum before collision that we name is at P before collision, that is 42.5 kg equal to 17/4 into V. Now we calculate it. That's 42.5 multiplied by 4 divided by 17. We see here that 4 multiplied 42.5 is equal to 10. Now therefore the answer is 10 meter per second is the answer fine. Part B, find the loss of kinetic energy of the system due to collision. Now we have to find the loss of kinetic energy. Firstly, we find the total kinetic energy before collision, and then we find the total kinetic energy after collision. We see that the total kinetic energy before collision, the kinetic energy of sphere A plus the kinetic energy of the sphere B before collision, that is equal to MUA square plus half MAUA whole square MBUB whole square. Now M is, we see that here is the M is given 5 kg, and mass of A is 5 kg and mass of B is 3 kg. We write it as 5 kg multiply speed of A is 8.5 meter per second. Now we write here 8.5 square plus 1 over 2, M is 3, but the speed of the sphere B is 0. Now we find this value, that is 2.5 multiply 8.5 whole square plus 0. Now you see that 2.5 multiply 8.5 square, we get 180.625 joule. We find the total kinetic energy of the system after collision. You know the kinetic energy of sphere B and sphere A. The kinetic energy of sphere A after collision, that's equal to 1 over 2 MA into UA VA square plus 1 over 2 MB into VB whole square. Now we substitute the value. M of sphere A is 5 kg and V is, here is the velocity of sphere A, that is 1 over 4 into V. Now here the speed of V is 10, we can write it 1 over 4 multiplied 10 whole square, that is the speed of A. Same as the speed of B is, here is given 1 over 2, the mass of B is 3 and speed of B is 10 meter per second square. Now we write it 10 square. And this value become 1 over 2 multiply 5, that's equal to 2.5 multiply, and that is equal to 1 over 4 into 10. You can write it 2.5 whole square plus, that's equal to 1.5 into 100. Now we check the value. Now the value of this total kinetic energy of the system, we calculate it here. Now you can see that 2.5 multiply 2.5 whole square plus 1.5 multiply 100. Now we get 165.25. That's the answer. 165.25. This is the total kinetic energy after collision. You can see that before collision the kinetic energy is 180.625 and after is 165.25. Therefore, the loss of kinetic energy will be equal to 180.625 minus 165.25. We get 15 joule SPM. Now, the next part. Here the coplanar forces of magnitude 60 Newton, 20 Newton, and 16 Newton and 4 Newton act at a point in the direction shown in the diagram. Find the magnitude and direction of the resultant force. We have to find the magnitude and direction of resultant force. Here are the component of forces given. Now we see that these are the forces 60, 40 Newton, 60 Newton, and 20 Newton. Firstly, uh, we resolve these forces into components. Here the first force we take as the 20 Newton. This is the 20 Newton force. And the component of this 20 Newton force along the horizontal, that is the horizontal component. And same as the vertical component, that is the vertical component. This is the vertical component, you can see. And horizontal component of the force will be equal to, F. This is the F is 20 Newton, that is 20 Newton cos 60. This is 20 cos 60 degrees is the horizontal component of 20 Newton. And same as we find the vertical component, that is equal to 20 into sine 60 degree. And same as the second force, I mentioned with the green color, where this is the second force. Now the component of second force along the horizontal will be this, and that is the another vertical component along this direction. Now this horizontal component value will be equal to 16 into cos 50 degree, and that value equal to that component value will be equal to 16 sine 50 degree. Now the forces are acting along the horizontal axis, we calculate it. Now the x component fx, that is equal to that is 20 cos 60 minus the force along the horizontal on left side is one is the 40 Newton, second is 16 cos 50. Now we write it 16 cos 50 degree minus 40 Newton. And same as we find the y component. So now therefore we can calculate it that value 60 Newton minus downward forces are here is these are the downward forces in the red, that is minus 20 sine 60 degree, and the force in green color is given here, this 60 16 sine 50 degree. Now we calculate these values. Now 20 cos 60 minus 16 cos 50 cos 50 degree minus 14, that value is equal to minus 14.28, minus 14.28. Now this is the absolute value. Now we can write it as 14.2. Okay. Now we calculate the y component value along the vertical direction, the forces along the vertical direction. Now here we see that 60 minus 20 sine 60 degree, then minus 16 into sine 50 degree, that's equal to 30.42 plus, and we write it as Fy, that is equal to 30.4. Okay. Now the net force will be equal to F will be equal to Fx whole square plus Fy whole square. sum of x component along the x-axis and the sum of the component along the y-axis. Now we write this value. Here the value is 14.2 whole square plus 30.42 whole square, and we get f square, that is equal to, and that is equal to 129.3, 129.3, and we take the square root on both sides, we get f equal to square root of 129.129.3. Now we get the answer. The answer is 33.60. This is the 33.60 Newton is the resultant force. And to find the direction, we know that the direction that is equal to Fy tan inverse equal into Fy over Fx. Here the tan inverse is into component of Fy is 30.42 divided by Fx is given here is 14.28. Now we calculate it. Now you can see here tan inverse 30.42 divided by 14.28, that's equal to 64.84. Now the 64.85, and that is equal to 64 point, you can write it as 64.9 degrees. And this is the direction of the resultant flux. And we go to the next part of this question. In question 3, two particles A and B masses 2.4 kg and 1.2 kg are connected by light in extensible string which passes over a fixed smooth pulley. A is held at a distance of 2.1 meter horizontal plane and B is 1.5 meter above the plane. The particles hang vertically and are released from rest. In the subsequent motion, A reaches the plane and does not rebound, and B does not reach the pulley. Okay, now in the first part, show that the tension in the string reaches the plane is 16 Newton and find the magnitude of the acceleration of before A reaches the plane. Firstly, we note down the data in this given problem. Here is the mass of two particles. Mass of A is 2.4 kg and mass of B is given here 1.2 kg. And the next statement here is the A is held distance of 2.1 meter above horizontal and B is 1.5 meter above the plane. Now we have to find firstly tension of the spring before A reaches the plane. To find the tension, we draw a figure here. Now here the two particles given, particle A having a mass is 2.4 kg. Now the weight is equal to mg, that is 2.4 into 10, 24 Newton. And the particle B here is given 1.2 kg, that is the 1.2 kg. The particle A is heavier than B, therefore now you can see that the body moves. The particle A moves downward and the particle B move upward because A is heavier than B. Therefore, the equation, the forces acting at A, firstly we see that the force acting at A, for A, the forces acting here, one is the tension of the spring, other is the uh, weight of particle A, that is weight of particle A is WA, and the minus tension, that is equal to net force. The net force will be equal to NA. And same as in this second for particle B, we see that the upward force is greater than downward force. Therefore, P minus WB will be equal to uh, the net force, that is equal to NA. Here the N is of particle A, that is M is equal to particle B. Now we substitute the value. The weight of A is 224 Newton minus P as a tension. M is 2.4. A is written as it is. P is tension written as it is. The weight of B is 12 Newton. That is equal to NB is the weight of the particle B. We know is 1.2 kg into A. Now this equation becomes P will be equal to 24 minus 2.4a, and that is equal to 12 plus 1.2a. Now we solve it simultaneously. Now that 24 minus 2.4a will be equal to 12 plus 1.2a. Therefore, now we shift the value of 12 from right to left side. We get 24 minus 12 and 1.2a minus 2.4a plus 2.4a. We get 3.6a into 12. Now we divide it. We get the acceleration that is equal to 12 over 3.6. Now you can see that 12 divided by 3.6, we get 10.3 is the acceleration. Now we have to find the tension of the spring. We substitute the value in this equation, that is T equal to 24 minus 2.4 into A is 10 over 3. We get 24 minus 0.8 into 10. That is equal to 24 minus 8. That is equal to 16 Newton. We have to show that the spring tension in the spring A before reach the plane is 16 Newton. Therefore, the answer is 16 Newton is the answer. To find the height of B above the plane, I form a figure here. I mention here two particles A and B, and the particle A is given in this problem is 2.1 meter above. I mention it, and particle B is 1.5 meter above the plane. Now the height of the B, we see that the particle B moves upward direction. The distance is covered in upward direction is same as the distance when the particle A moves downward direction. You see that when it moves downward direction, the particle move in upward direction, and that is the distance it covers in upward direction is 2.1 meter. And when the particle A reaches at this position, the particle B uh, move vertically upward with some velocity and reach at the position when its velocity becomes zero. Now, we therefore the total distance it covers in upward direction is 1.5 meter plus 2.1 meter, and that is the distance covered from at this position to that position where its velocity becomes zero. Now we suppose that that is equal to h. Now to find the value of h, to find value of h, the equation we use that is s equal to h, and that we use is 2s equal to v square minus u square. And here the speed of velocity of v square is 0 and u is not given here, but 2 is now the acceleration is 10, and we can calculate the distance catching upward. If we find the initial speed u, we can find the distance in the upward direction. To find the initial speed, we see that the speed at which the particle A strikes the ground, that speed is equal to the initial speed of the particle B when it reaches above 2.1 meter above from this position to that position. Now at this position, the speed of initial speed of UB will be equal to VA. Therefore, to find VA, we use this data of the particle A movement in downward direction. We see that the for A particle, we see that the initial speed of A is 0 and the distance it covers is 2.1 meter. And now we use the equation to find the velocity of VA, where 2as equal to v square minus u square. Here the acceleration is given. We already find its acceleration when the particle moves downward. That is equal to 10 over 3 meter per second square. Now we put this value now 2 into 10 over 3 into s is 2.1 meter. That is equal to v a square will be equal to that u is 0. Now this value will be equal to when we simplify this, we get VA square equal to 14 meter per second. Okay, now we put the value here because the initial speed of B is equal to uh, final speed of V when it strikes the uh, Earth. Therefore, we can put this value here is 14. U square B will be equal to 14 because UB equal to VA. That is VA. Sorry. Now here we can find this value minus 20H because the A is here is negative. Now we put a negative because particle B is moving upward, the acceleration will be negative. Now we get minus 14 and H equal to 14 over 20, that is equal to 0.7. The total distance covered will be equal to 1.7 plus 2.1 plus H equal to 0.7, and that is equal to 6 and 7, 12, 13, 1, 2, 3, and 4.3. This is the answer. Question 4. A particle A moving along a straight horizontal track with this speed, constant speed, 8 meter per second, passes a fixed point O. 4 seconds later, particle B, now this is the particle B, passes a moving along a parallel track in the same direction as a particle B has speed 20 meter per second. It passes a constant deceleration 2 meter per second and comes to its returns to its position. Now find the expression in terms of the displacement of each particle t second after B passes away. We draw here a figure. This is the particle, so this is the particle A, and it's when the time t is equal to 0, it starts its motion. It's moving along this track, so it reaches at this position at 4 seconds, and after this it reaches t second later it reaches at this position. This is the time taken is total time taken from starting motion to end point, that is equal to, so t is the time and 4 seconds that time it takes. This is the total time is t plus 4. Now here the speed is also, we write it here, the speed of the particle. The speed is constantly, where you can see that the speed is constant speed 8 meter per second. Now on the same track, the particle B starts its motion. So in the same track, it starts its motion. This is time t equal to 0 and B is given here is 20 meter per second. And acceleration, you can see that is the acceleration of particle A is 2 meter, deceleration is minus 2 meter per second square. Now here this you can, okay. Now after t second later, the time taken is t, it reaches some position. Now we have to find the displacement of the element. We know the formula of the displacement distance will be equal to V multiplied T, V average multiplied T, because the speed is constant. Here the speed is constant and we can take the value. 8 multiplied time is with T plus 4, and we get 8 times T is 80 plus 32 meter. This is the expression of the particle A motion. Now next we will find the expression of displacement, find the expression in terms of T for the displacement of particle B. Now here we find the displacement of particle B. This is the particle B motion. Particle B motion. Now without this, here you can see that the time is given, speed is given. This is the initial speed. Acceleration is given. Therefore, to find distance as equal to 2t plus half at square. This is the equation, second equation of uniform motion. Now, substitute the value u is 20 and time is taken as t because in time t we have to find the displacement expression. Now, after this, 1 over 2 as it is, a is minus 2 time is t square. That equation becomes 20t minus t square. This is the second particle B distance, and this is the particle A distance. Sorry, particle A displacement, and this is the particle B displacement. Now, next part of this question. Particle B, find the values of T when the particles are the same distance from it. Now, we already calculated the distance of particle A and distance of particle B. Now, we write here. Now, the distance of particle A is 8t plus 32, and distance of particle B is 20t minus t square. We equalize the both values. Now, we get SA distance will be equal to SB. 8t plus 32, that's equal to 20t minus t square. Now we shift all values from right to left side. We get t square minus 20t plus 8t plus 32, that's equal to 0. Now that it becomes 2 square minus 12t plus 32 equal to 0, and we factorize this expression. Now make a factor of 32. 4 times 8 is 32. Therefore, the factor it would be minus 8t. The expression becomes minus 8t minus 4t plus 32. Therefore, now we take the common first two terms, t minus 8, it becomes 10 minus 4 common, it becomes t minus 8, and that's equal to 0. And therefore, now t minus 8 into t minus 4 are the two factors of this expression. Now, either is t minus 8 equal to 0 or t minus 4 equal to 0. Therefore, t will be equal to 8 seconds and t will be equal to 4 seconds. In part C, on the given axis, sketch the displacement time graph for both particles for values of t from 0 to 20. Now here the displacement of particle B, particle A is given 80 plus 32. Now to draw the graph, we take some values. T is 0, dash will be equal to 32, and we take t equal to 4. Then x will be equal to plus 8 4 the 32 plus 32 64. Now we take 2 points and draw the graph here. Suppose this point is 50, and this is the 1, 2, 3, 4, and that point is 32. And this point is hidden value is 5 seconds, and this point is 4. And the value of t equal to 4 is 64. We take this 60 and 64. This point is, I think this will be the point. And we draw the graph here. No, this is the 64. This point is 64. 1, 10, 20, 30, 40, 50, and 60. This is the point 64. And this is the straight line. Now the next phase has to be equal to 23 minus t square. This is the quadratic graph. Now we take some value for to find the value of distance. When t is 0, you see that s will be 0, and when t is 20, s will be 20. Now we take another point, this turning point. We take the derivative of this st as our dt is equal to 0. We get 20t minus t square equal to 0. We get 20, sorry, 20 minus 2t equal to 0, we get t will be equal to 10. At this position, the distance will be equal to 10, 20 to 10, 200 minus 100, that is 100. That is the 100. Now we mark the point 100 here. Now, now we draw the displacement time graph for the particle B. Here we join the point t is equal to 10, that is 100, that's 100 meters. The distance is 100 meters. And when t is 0, displacement is 0. When t is 20, displacement is 0. Now we join these points. And this is the graph of the particle B displacement. This is the displacement time graph. Question: find a block of mass 12 kg placed on a plate which is inclined an angle 24 degree to the horizontal, light swing making angle of 36 degree above a line of greater slope is attached to block. The tension in the spring is 65 Newton. The coefficient of friction is mu, and the block is in limiting equilibrium, and the point is sliding up the plane. Now we see the information here given. This is the block is in limiting equilibrium. It means that the force acting on this block on along the surface on right side is balanced by the forces acting on the left side. It means the acceleration of the block will be zero. So now we see the forces acting on the block. Is the first is the tension of the spring, and next is the force acting on this block is the weight of the block. Now you can see this is the in vertical direction. And next is the frictional force, which is here is the statement given. The point at the block is at the point of sliding up the plane. It means that the friction acting on in the downward direction along the surface. Now we form the component of these forces. The component of the force 65 newtons. We see that the component along the surface of the 65 Newton, it would be this in this direction, and the perpendicular direction the force acting is this, and now these component will be this is the 65 cos 36 degree, and next is the perpendicular to the surface, it would be 65 into sine 36 degree. These are the two components. Now next is the we take the component of the weight of the body. Now the weight is W, and so write it that's like now the component of the perpendicular to the surface is this will be this is the force which is perpendicular to the surface is W cos 24 degree. Angle of making with the plane is 24. This angle will also be 24 degree. Now the next to find the component along the surface of the this direction W sine 24 degree. The friction between the block and the surface. Now this is the frictional. To find the uh, new value, take the forces acting on the along the surface. Now we see that the forces acting on the block on right side here. This is the 65 cos 36. The forces acting on the left side along the surface. One is W sine 24 plus frictional force. The forces acting on the block perpendicular to the surface. These are the forces. First is 65 cos 36 sine 36 degree. Another other force acting on this block is the reaction of the surface on the block. That is the this is the force acting on in upward direction. That is the reaction of the force. Now therefore 65 sine 36 plus r surface. Now the forces acting on in downward direction perpendicular to the surface is W cos 24. That will be equal to W cos 24 degree. Because the block is in limiting equilibrium, it means that the forces acting on the block uh, on the left side will be equal to right side and the upward force is equal to downward forces. Now we find the frictional force is mu r. We can write it as mu r. That is the frictional force. Okay, now we find the value. Here is the r is equal to W cos 24 degree minus 65 sine 36 degree. That there is mu r is equal to 65 cos 36 degree minus W sine 24 degree. And where is the r is given? That is the value of r. Now we put here mu into W cos 24 degree minus 65 sine 36 degree equal to 65 cos 36 degree minus W sine 24 degree. Now therefore mu will be equal to 65 cos 36 degree minus W sine 24 over W cos 24 degree minus 65 sine 36 degree. Now the weight of the body here is the block is mass is M 12 kg and therefore the weight of the body will be W will be equal to mg and that's equal to 12 into 10 120 Newton. Now the weight of the block is 120 Newton. We write it as 65 cos 36 minus 120 sine 24 degree over 120 into cos 24 degree minus 65 sine 65 cos 36. Now we calculate it sine 24 degree divided by 120 cos 24 cos 24 degree minus 65 sine 36 degree. Now we see the answer is 0.05289. This is the answer 0.9. Now The three significant figure, that's value equal to 0.0529. This is the coefficient of friction. Now next question. Question 6. A car of mass 900 kg is moving up a hill. Incline at sine inverse 0.12 to the horizontal. The initial speed of the car is 11 meter per second. After 12 seconds, the car has traveled 150 meter up the hill and has a speed 16 meter per second. The engine of car is working at a constant rate is of 24 kilowatt. Find the work done against the resistive force. Now here we draw the inclined plane here to solve this question. This is the inclined plane making angle 20 sine inverse 0.12. Now the angle is sine inverse 0.12. The mass of the car is 900 kg. At the starting point, the car starts its motion here. Now, take the car here. And after 12 seconds, the initial speed of the car is 11 meter per second. We write it 11 meter per second. And after 12 seconds, the car has traveled 150 meter up. Now the time is, this is the after 12 seconds, 12 seconds later, car it covers 150 meter up the hill. 150 meter is covered the distance 150 meter up the hill, and it reaches at this position. And at this position, the height of the car we take as a h. We take this is h. Now we see that the inclined length is 150 meter, vertical length is h. Now opposite side our hypotenuse h over 150, that's equal to sine theta, and theta is the sine inverse 0.12. Now we get h will be h over 150 equal to 0.12. Now we multiply 150 to 0.12, we get 18 meter height. The height is 18 meter. Okay. Now we see that the speed of the car at the top is here is 16 meter per second. We write it as 16 meter per second. And to find the work done against resistive force, find this value using work energy relation here. That is equal to work done by net force. Work by net force will be equal to change in mechanical energy, the total energy change. Now we write it. Okay. Now here the net force, work done by net force equal to work done by driving force minus work done by resistive force. That's equal to total change in potential energy plus total change in kinetic energy. Okay. Now here the work done by driving force. We see that therefore the work done will be equal to, we know P equal to W over T. Therefore W will be equal to PT. Now we can write it as PT here, and we have to find the work done by resistive force. Now the potential energy, total potential energy, we have to find MPH H2 minus H1 plus kinetic energy. We will use the formula half mv square minus u square. Now we substitute the value. Power is the 24,000. Multiply the time is 12 seconds minus WR, that is equal to Now, here is the mass is 900 kg, 900, and G is 10. Now that's become 9,000. The height, here is this is the 18 meter plus 1 over 2, m is taken as 900, and v square, this is the final velocity, and this is the initial velocity. Now we write is 16 square minus. Now we multiply this, we get 2. Now we solve 88,000 minus WR, that is equal to 9,000 multiplied 8. Now we see that 9,000 multiplied by 18, we get 16,000, 16,2,000. Now we can say that 16200 plus that's 900 divided by 2, we get 450. And same as the 16 square minus 11 square, we see that 450 multiplied bracket 16 square minus 11 square, we get the value 6750. Now 60,750, 60,750. Okay, now we have 60,750. When we multiply these values, we get. Now, here is the values given is 16,2000. WR is 7800. And now to find WR, we can find easily. WR we shift from left to right side, we get 2,88,000 minus 16, 1,62,000 minus 6,750 equal to WR. We can calculate it. Now we get 65,250. 65,250 joule is the resistive. It is the work done by resistive force. This is the answer. Now we go to the next part. Now P part, find the speed. You can see that the resistance of the car is 1,520 plus 4 V Newton, and the speed of the car is V. The car travels at a constant speed, and the power of the engine here is given 32,000 watt. Now we see that the forces acting on the car is the one is the applied force. So this is the car, and forces acting on this car is one is the driving force, and another is the resistive force. You can see that the car is traveling with the constant speed, it means the resistive force will be equal to driving force. Therefore, here's the given is the power is given. Power is the 32,000. Power is 32,000 watt, and the speed of the car is, you can see that is the this is the power is equal to F into V. You can write it. Therefore, we have to find the speed of the car, that will be equal to P over F, and this is the force acting on the car, if that is equal to Ft, that is Ft equal to R. Therefore, we can use this force value here. Now the driving force value will be equal to 1,520 plus V. Therefore, we put this value in this equation. The power is 32,000 and force is 1520 plus 4V, that is equal to V. Now we calculate it. 32,000 equal to 1520V plus 4V square. Now 4V square plus 1520 minus 32,000 equal to 0. Now, so we divide this equation by 4, we get V square plus 3 and 4 3s are 12 and 3 4 8 32 380 minus 4 32 8,000. Okay. Now we take the factor 400 multiplied 20, we get 8,000 and when we subtract this 400 from 20, we get 380. That is, sorry, this is the 120 V and 380 V. Therefore, we can write it as V square plus 400V minus 20V minus 8,000 equal to 0. Now it becomes V plus, this taking as common, V plus 400 minus 20 is common. Now V plus 400, that's equal to 0. Now V plus 400 into V minus 20. Now these are the two vector we get. Here we take V plus 400 equal to 0 and V minus 20 equal to 0 and we get V equal to minus 400 and this is the V equal to 20. Now this value we see that there is minus 400 meter per second speed. It's not possible because it is very high speed and next phase is in the opposite direction. Now this value is not possible and this is the answer we take care. If particle P moves in a straight line, the velocity at time t second is given by v equal to 0.5 t and v equal to 0.25 t square minus 8t plus 60. Show that there is instantaneous change in acceleration for the particle at t is equal to 10. Firstly, we find the acceleration for the first equation and then second equation. To find the acceleration, we take derivative on both sides of this equation. Now with v is equal to 0.5 t. Now for the interval t is equal to 10 to 0. Take derivative on both sides dv over dt, and that is d over dt is equal to 0.5 t. We get 0.5 into 1, that is equal to 0.5 meter per second square, and that is the acceleration is constant for whole interval. Therefore, for t equal to 10, the acceleration will be equal to 0.5 meter per second square. Now, for the second interval, we see that here velocity is given as 0.25 t square minus 8t plus 60, and for interval t is equal to 10 to 20 seconds. Now we find the acceleration. We take derivative on both sides dv over dt, and that is become 0.25 multiplied 2t minus 8 into 1 plus 0, we get 0.25 multiplied 2, we get 0.5t minus 8, and for this is the acceleration for time t is equal to 10. We see that that value becomes 0.5 multiplied 10 minus 8, and that value is equal to 5 minus 8, and that is minus 3 meter per second square. Therefore, here the acceleration at t is equal to 0.5, and that is second acceleration at t is equal to minus 3.9 minus 3 meter per second square. This shows that the instantaneous change in acceleration. Question 7, part B. Find the total distance covered by P in interval 0 to here. v equal to 0.5 t. To find the distance, we have to integrate on both sides. Now, to integrate both sides with respect to t, that's equal to distance of the uh, moving body. Now, that is the interval is 0 to 10 seconds. Therefore, that is equal to the distance covered in the interval 0 to 10 seconds. We find this. The integration of 0.5 into t is t square over 2. Now the interval is 0 to 10 seconds. Next is 0.5 t square over 2, that's equal to 0.25 t square, and the interval is 0 to 10 seconds. Now we put the value uh, in the first upper bound value of the interval is 10. Now the 10 square minus 0, and that is equal to 24 meter is the distance covered in the interval. Velocity 10 to 20 seconds here is, this is the velocity, is 0.25 t square minus 8t plus 60. To find the distance, we integrate this equation. When we integrate this equation, we take the interval 10 to 20 seconds. And you see that this is the quadratic expression. In the quadratic expression, firstly, we have to find where the velocity is 0, and we have to find the time where the velocity is 0. And from this, we can calculate the distance of the of this interval, because when we integrate this velocity in the interval 10 to 20 seconds, this interval shows the displacement, but we have to find the distance covered in this interval. Therefore, firstly, we the velocity, we find the time where the velocity is 0. Therefore, we suppose v is 0. Now we find the time 0.25 t square minus 80 plus 60. Now we multiply by 4, we get 1 t 4 multiplied 0.25 t square minus 4 it's a 32t plus 240, and we get t square minus 32t plus 240 equal to 0. Now to factorize the 240, and we see that 12 multiplied 20 is the factor. When we add these two numbers, we get 32. Therefore, we solve it. T minus t square minus 20t minus 12t plus 240 equal to 0. And that's equal to t minus 20 minus 12 and t minus 20 into equal to 0. That is t minus 20 into t minus 12 are the factor of this quadratic expression, and t equal to 12 and t minus 12 equal to 0, and thus t minus 12 equal to 0 and t minus 20 equal to 0, we get t equal to 12 and t equal to 20. Therefore, the interval at which the acceleration velocity is 0 at t 12 and t 20. Now we take the interval for to find the distance here. We see that that is v equal to 0.25 t square, v equal to 0.25 t square plus minus 8t plus minus 8t plus 20 plus 60, sorry, plus 60. Now to find the distance from the interval 0 to, firstly we find the interval 10 to 12, and then we find the distance from interval, second interval 12 to 20 seconds. In the first interval, we see that is the distance we can find by integrate this interval v dt plus v1 dt, we can say this, and v dt this. Now we get the distance S1, S2, and S3 distance. Now, this is the distance S2 in the interval 10 to 12 second, and that next distance is 12 to 20 second. We integrate this is 0.25 t square minus 80 plus 60. Integrate 10 to 12 for 10 to 12 second, and same as we integrate for 12 to 10 second. Now integrate it, we get 0.25 into t3 over 3 minus 8t cube over square 2 plus 60t. Okay. Now we integrate this expression 12 to 20. We see that the same answer here will be taken. Now 0.25 over 3 we see this is the answer is 0.25 divided by 3 we get 1 over 12. Now we write it as 1 over 12 t cube minus 4t square plus 60t. Now here is 60t, we write it plus, and the interval is 10 to 12. And same as is 1 over 12 t cube minus 4t square plus 60t and 12 to 20. Now for the interval for 10 to 10 we get 1 over 12 into 10 cube minus 4 times into 12 square plus 60 into 12 minus, now put the value 10 here, 1 over 12 into 10 cube minus 4 times 10 square plus 60 into 10. Now for the second expression here 1 over 12, 1 over 12 into 20 cube minus 4 into 20 square plus 60 into 20 minus, that's the second expression value, now minus, now we put the 12. 1 over 12, same 12 cube minus 4 times 12 square plus 60 into 12. Now we find the answer. Now we see that 1 over 12 multiplied 12 cube, that's equal to 12 square minus 4 multiplied 12 square plus 60 multiply 12, we get 288. We write it as 288 minus, next is 1 over 12, 1 divided 12 multiply 1000, 10 power cube is 1000 minus 400 plus 600, we get 850 over 3. Now we write it 850 over 3 and plus next value 1 divided 12 multiply 20 power 3 minus 4 multiply 20 square plus 60 multiply 20. Now we get the answer is now 22 minus 4 multiply, we check it again 20, that value becomes 4 into 20 square plus 60 multiplied by 20. Now we get the answer 800 over 3. We write it 800 over 3. Now this value is same as we already calculate it 1 over 12 into 12 cube, we get to 288. Now we write it minus 288. Okay. Now we find this value. Now 288 minus 850 divided by 3, we get 14 over 3. Now we add 14 over 3. Next is value. We find this 800 divided by 3 minus 288. We get minus 64 over 3. Now that value is minus 64 over 3. You know this is the absolute value. The answer is positive. 14 over 3 plus 64 over 3. We get this is the 8 and 78 over 3, and this is the 26. Now we have to find the total distance. You see that here is the total distance will be the distance in this interval. This is S1 and this value is S1. We already find, and this in the second interval for t 10 to 20 seconds, we see that the interval becomes 10 to 12 and then is 20. Therefore, that is S2 plus S3. S equal to S1 plus S2 plus S3. Here S2 plus S3, this is the S2 plus S3 distance. S2 plus S3 distance is equal to 26 and S1 distance is 25. We get 51 meters of total distance covered in this interval.